All right, guys, time for lesson 3 of our tutoring training. In this video, I'm going to talk about physics and chemistry tutoring and how to decide what method to use when you have a variety of methods before you. I first want to introduce the idea of distancing. The distancing means that the student, instead of physically and concretely understanding what the subject matter is, they're just trying to just say, like, let me keep this out of my mind. I'll short-term memorize some formulas and make sure I just don't know any of this. Please, God, keep the actual physical understanding of this outside of my mind. Let me just plug some numbers into formulas. So over here, I've drawn this circle, and here you've noticed that I've marked the diameter of 6. And I often use this question with younger students. So I'll have a circle, diameter 6, and say, what's the area? And these are students where I've checked to make sure that they know that the area is pi r squared. About half of students do it in a second. They say, okay, the diameter is 6. I can easily see that the radius is 3, and they solve it in a second. The other half of students are totally stumped. They can't do this at all, because what happens is they've memorized pi r squared, but they don't know what it means. They don't know what r is. They don't understand what a radius is. They can't look and easily glance and see that the radius is half the diameter. And so what they are going to be hoping for is a formula that converts diameter to area. And some books, foolishly enough, actually include such formulas. And they'll try to look it up and use that. Because all they're doing is they're just looking at formulas. They're not trying to actually imagine the circle, or in this case, even look at the circle. They don't have to imagine it. It's literally right there. That's distancing, and that's the thing we want to prevent. That's the worst. That's like the kiss of death for any student's grades or understanding or whatever you want to focus on there. A student who's doing distancing is going to fail the exam. Guaranteed. He's going to fail every test or get a C on every test. They'll get A's on most of their quizzes because what they're doing is they're short-term memorizing every formula. So they have more formulas, quicker formulas for this one little topic, but they're going to fail the exam. That's obviously not what we want, not what they want, not what anyone wants. So let me show you how this principle will relate to, and I'm going to start off with a basic physics concept. Here I have two vectors, and I've arranged them head to tail. There are many ways to add these vectors. There's a lot of ways to add these vectors, right? One is you can find that you can find this angle over here and use the law of cosines. That's probably the brute force fastest way to do it. I would never, ever teach that. I would never teach that method. Here's why. If somebody's struggling with adding vectors, it means they're not imagining adding vectors, not visualizing it, even when it's drawn. If it's not drawn, they're not going to draw it. They don't get what it is. They don't get that this vector here is going more to the right than it's going up. They don't understand that it's broken components. They don't get what a vector is, right? All they get is that if they find this and they find this and they somehow get this angle and they do the law of cosines, they'll get that. That's one way to do it. Another way to do it is we can put these vectors tail to tail and then use a parallelogram method, right? Finding the diagonal of the parallelogram. And again, I wouldn't use that at all because while it works, it's not physically obvious why it works. Now, to some of you guys, it might be physically obvious because some of you guys have IQs that are just way too high for words. And some of you guys, when you look at the law of cosines, you're like, oh yeah, I can totally imagine and picture that. That's amazing, and I'm glad that you guys are here at Vora Method because we like the fact that our tutors tend to be among the best in the whole world. But that is not a level of cognitive skill that the average high schooler has. And even high schoolers who could do that, when they're in the state of fear and anxiety and panic and distancing, in their current state, they can't do that. Maybe in a year they'll be able to, and you could have that discussion with them. They'll be like, oh yeah, I totally see how the law of cosine makes sense over here. So that's what you shouldn't do. I wouldn't recommend the parallelogram method. What I would recommend is just the most basic, almost clunky method. Let me just get rid of that circle here. The most basic method, which is to just take the vectors, break them into components first. First, see, can they break a vector into a component? If they're struggling with physics, the answer is they probably can't. So the first thing, you have to make sure they can break vectors into components. That might take some time. Make sure they understand that breaking vectors into components is one of the most important skills in physics. I would say it's the most important skill in physics, but it's certainly in the top 4. We'll break this into components. And I know I haven't labeled the angles or sides, but you guys get the idea that you would actually have the sides and angles and you would get these components. And now what I do is I pause and talk about this a bit. Let them talk about it. Let them see the idea. And this is an idea that people can concretely grasp. When you go this way, it's like you're going this way a bit and this way up. It's the equivalent. I've arranged these vectors head to tail, which lets you know that first you're going to go here, then you're going to go here. And that also is something that people can understand, right? If you use the parallelogram method, say you're going to go here, then you're going to add this vector over here. It's just not. No one can. It's not intuitive to follow. So you want to use the most basic intuitive method, so that there's something you can build on. And then from here, I would just say, you add up the horizontal vectors, you get this big giant thing here. You have the vertical vectors, you get this big giant thing here. And then, instead of the law of cosines, we're going to just use the Pythagorean theorem. So we're using the thing that's the easiest to visualize. Now, this is not the quickest to do. The quickest to do is the law of cosines. This is the easiest to visualize. This is the most likely to lead to an actual concrete understanding. Now, even with this, students are still going to try distancing. So you're going to have to repeat with the review questions. You're going to have this discussion a few times, right? Because once you can get a student past that distancing phase, right? You get a student past the phase where they're just trying to avoid the subject and have them actually build this concrete understanding, they're going to already be at the top. I mean, people ask, like, how do we always talk about how we turn D students into A students. People are like, how in the world could you turn a physics student, like, in late March from a D student into an A student? Because it's just one thing. Their D is for distancing and A is for awesomely not distancing. If you can get a student in physics or chemistry or anything like that to stop the distancing, to build an understanding, then they're going to dominate the exams, because everyone else in their class is distancing, and that's pulling down the average level. They're going to do super well in the test. No, they'll probably do okay on the quiz, but honestly, no one cares about a quiz. So that's what I want to do. Let me just really briefly talk about a chemistry example. I'll talk about some of these more in a video. This is something that Kimia pointed out. In chemistry and physics, the biggest issue is just vectors, that they can't break down vectors. The second biggest issue, by the way, those guys who are doing physics, is that people believe that normal force is always the up force. They don't understand that it's the force, essentially, of electrostatic repulsion, where if you're pushing your hand into a wall and your hand's not going through the wall, that's normal force pushing back. Those type of things, they don't really get that. So, but the biggest one is vectors. You get that vectors stuff actually concretely understood. That'll be huge for most students. In chemistry, Kimmy pointed that most people can get the idea of sharing in a covalent bond, but the idea of unequal sharing, that one side can be stronger than the other, have more electronegativity than the other side, and therefore be a little bit negative, that's where people get thrown off. And of course, then with polar molecules, nonpolar, they can't think through that second stage of chemistry. Anyway, so we'll be talking more about physics and chemistry and all those different calculus and all those different areas, but this basic idea of trying to do whatever you can to overcome distancing is very, very critical here. If you stop the distancing and you have them build on a concrete understanding, you're going to get great results.